Okay, so this is 12.5 continued. So this is about curvature dissection. So think of driving along a curved road in your car. In order to stay on the road, you must make adjustments to your steering wheel. At any point on the road, if your steering wheel locked, your car would trace out a circle. 1 over the radius of the circle is called a curvature at that point. So let me draw the picture here. Okay, so I've drawn a picture here. Suppose this is our curved road. So suppose you're driving in your car along this curved road. And when you get to this point here, say your steering wheel locks. These wheels don't move here, but your steering wheel will be your wheels will be like pointing that way, say. If your steering wheel locked, then you trace out a circle. And the 1 over the radius of that circle would be the curvature at that point. So imagine you're going around this curve here, this point here, your steering wheel locked, you trace out a circle then, you're on a circle, and 1 over the radius of that circle would be the curvature. Okay. And we write the curvature with a K. So at this picture here I've drawn the curvature at T0, so here's at RT0. So the curvature, say at time 0, is 1 over R. Okay, so now let me give you a formula to find the curvature in general. So here's a formula for curvature. Okay, so here's a formula to find the curvature in general. It's defined to be the magnitude of capital T prime over magnitude of R prime. And recall the capital T. This is the unit tangent vector is defined to be R prime over magnitude of R prime. Okay, so now let's take a look at an example. So I'm going to erase this stuff now. Okay, so example, this is from practice quiz 3, number 4. Just find the curvature of the curve at t equals -1. And here is our curve here. And it's r of t equals square root of 8ti plus 1 over tj. Okay, so let's write our curvature formula. Okay, so here's my curvature formula, and here is the definition of capital T, or the unit tangent vector. So let's find r prime first. So the derivative of square root of 8t, which is going to be square root of 8 in I direction, plus 1 over t derivative would be, you can write this as t to the -1. So it's going to be minus t to the -2. Let me write that here. Okay, first I wrote 1 over t as t to the -1. Now I'll take derivative. Okay, let me write my r prime right here. So I get this then. So again, square root of 8t derivative would just be square root of 8. Derivative of t to the -1 would be -1 t to the -2, which I have here. Let's find the magnitude next. Okay, so let's find magnitude. Let me write it here. So the magnitude would be square root of 8 squared and minus t to the -2 squared. Okay, simplifying this, square root of 8 squared is just 8, and then you multiply exponents here, the minus sign will go away here. So let me write what we get. So we get this, and then the square root you can write as raised to 1/2. Let me do it. Okay, so writing it to the 1/2 power. Okay, now let's find our capital T, our unit tangent vector, using this formula here. Let me write it down here. Okay, so my capital T will be r prime, which I've written here, then 1 over the magnitude guy, which I've written here. I can bring this up and write as a negative exponent. Let me do that right here. So we get this then. And I'm going to call this guy here, let's call it, say, f. I'm going to call it f, and I'm going to multiply the f in here to each of these. So let me write here. So multiplying the f, and then you'll get square root of 8 f I minus f times t to the -2j. Now, we need to find, for the curvature, we need to find capital T prime. So let's take derivative now of our capital T. Let's do it down here. So taking derivative then, so the derivative of f here, which I have in the I direction. Here then, on this guy over here, we're going to have to use a product rule. I pull a minus sign out in front here, and then it's going to be derivative of first function. The first function is the f function, so it'll be f prime times the second function, which is t to the minus 2, plus first function, my f, times derivative of second. The derivative of t to the minus 2, you bring minus 2 down, subtract 1 from the power, so it'll be minus 2 t to the minus 3. So that's a product rule right here. Okay, now let's find f prime. Let's write it over here. Okay, so here's my f up here. So I'm going to take derivatives, so you're going to have to use the chain rule. So you're going to take the minus 1/2 here, bring it in front, like I did here. Subtract 1 from it. This should be actually minus 3/2 here. Because you subtract 1 from the power, so it'll be negative 1/2 minus 1, which would be negative 3/2, times derivative of the inside. So derivative of t to the minus 4, you bring the minus 4 in front, subtract 1 from power, so it'll be minus 4 t to the minus 5. Okay, so now we have to find the curvature when t is minus 1. So let's start now evaluating when t is minus 1. Okay, so let's find f prime of negative 1. So I'm going to put negative 1 in place of t here and here. So doing that, this should be minus 1 here. Okay, so working that out then, that's going to be 9 inside there, and that's going to be 4 here, times minus 2, so let me write it over here. So we get this, so this one here, it's be twice here. So let's keep going. So simplifying further, it's going to be minus 2 over square root of 9 cubed, that's 9 to minus 3/2. And it's going to be 3 cubed, so it's going to be minus 2 over 27, because 3 cubes 27. Okay, let's find now f of negative 1. Here's my f up here, so let's evaluate at minus 1. So putting negative 1 in place of t up here. So look at this, and that's going to be 9 then to the minus 1/2. So be 9 to the minus 1/2, which means 1 over square root of 9, which will be 1/3. Let's next find now capital T prime of negative 1. So evaluating at minus 1, so putting minus 1 in place of t everywhere. We get this then, and then we know what f prime of negative 1 is, we know what f of negative 1 is, so I can replace these now. So let me do that. So we get this then, making no substitutions, and then combining these here, you can multiply top and bottom by 3 here, sorry, by 9, be 18 over 27 minus 2 over 27, so it's going to be 16, it's going to end up being negative 16 over 27, so let me write here. Okay, so we get this then. Alright, so running out of space here, so I'm going to erase a few things, so let me summarize what we have and we'll keep going. Okay, so summarizing, we found capital T prime of negative 1 was this guy here, and we also have our magnitude of r prime is this guy. Let's evaluate this guy now at minus 1. Okay, so the magnitude of r prime of negative 1 then will be negative 1 to the negative 4 plus 8 to the minus, sorry, to the positive 1/2. That's going to be then 9 inside there, so it'll be 9 to the 1/2, which is square root of 9, which is 3. So we got everything we need almost now for the curvature. We just need to find the magnitude now of our capital T prime of negative 1. So let's find magnitude here. Actually, before taking the magnitude, I'm going to realize we should note here we can factor out a negative 2 over 27 out of these. It'll make finding the magnitude easier. So factoring it out, you'd have a square root of 8 left here, I, and then 8j left here. So I just factored out the minus 2 over 27. Now let's take magnitude. Okay, so when I take the magnitude, then the negative 27 in front pops out, but it'll be an absolute value around it. Okay, then it'll be this guy squared plus this guy squared. Okay, it's going to be 64 and 8, it'll be 72 here, right over here. Okay, so it's the square root of 72 here, which you can break up as square root of 36 times 2, square root of 36 is 6. Then as you can cross a factor of 3 off here, and you can check it becomes 4, square root of 2 over 9. Okay, so now we're ready to find the curvature at minus 1. Okay, so let's find the curvature. Okay, so find the curvature at minus 1. So stick into the curvature formula at minus 1. So the magnitude of capital T prime of minus 1 we found was this guy, goes here. Then divided by this one, which we found here. Okay, and so it'll be multiplied by a third. So it's going to be 4 square root of 2 over 27. So that's our curvature at minus 1. Okay. So if you sketch the graph of this guy up here, so it'll be some sort of a curve, at minus 1, this should be the curvature. Okay, so we're done. So let's leave it there.